I'm Tim Ventura, and we're joined today by Oscar Martin, a strategy, innovation, and transformation executive. Oscar's extensive career experience includes executive and technical expertise with cutting-edge technologies, helping design the early smartphones with Hewlett Packard, designing torpedo stabilizers with BRS Aerospace, developing the video technology used in the Nasdaq building, and leading the development of several subsystems of the Galileo satellites, as well as the European GPS. Oscar has also restructured several companies, including the 22-site GKN Aerospace in North America, and has worked in the energy industry with the AKO Group, leading the team designing, manufacturing, and building the electrical control software and hardware for nuclear and solar plants. Our focus today are the challenges and proposed solutions to meeting the world's energy demands. Well, so welcome back. You have been a vocal advocate for nuclear power for several years now, but in social media, especially over the last few months, I'm starting to see other folks advocating for it as well. So one of the things I wanted to jump right into was, are you seeing the pendulum starting to swing from the fear-mongering and towards the benefits of nuclear energy and power?
Absolutely. I think that most of the people and the organizations, I mean, it's not only it's not only me, but there are many part of our society that is moving to supporting nuclear. Not only the green advocates, but also governments, investors, and recently the AI companies. Financial institutions. Last week, 14 banks, global banks, were supporting the deployment of nuclear energy, and the public support is also growing here in the States and even in Germany. That has a clear anti-nuclear government. Actually, about 70% more, not 70, about 65% of the population supports nuclear energy. And why this shift? Well, basically, I think that it was the failure of solar and wind, because they are intermittent and they are very low density power sources. So we need to get 1 megawatt hour. You don't need 1 megawatt of solar and wind during 1 hour. You need a lot more than 1 megawatt. Why? Because the capacity, they are not producing 24 hours, 7 days a week. They're producing basically solar is about 6 hours on average per day, in the best case, and for wind is a little bit more, but not much more, about 8 hours or so. So that creates a huge problem, because it becomes a lot more expensive than the reliable energies that they are supposed to replace: nuclear and coal, gas, oil. So the problem here is that, yes, it's very inexpensive. Solar and wind is very easy and very inexpensive to build, but they require so many ancillary systems at the grid level that even that part is very inexpensive. The whole system becomes very, very expensive, because you need a backup system that is also a cost. So for each megawatt of unreliable energy, you need a backup that adds to the cost of reliable energy that is idle, waiting for activation. So that's a problem. And all that, the huge cost, that is something that no one was anticipating, is something that experience is telling us. Here in California, we have experienced, in the last 10 years, we paid twice the cost per kilowatt hour here in California. So so that is one of the reasons. The other is that most of this technology is coming from China, and China is not a reliable partner. And for critical things like defense or energy, you cannot rely on external sources. And nuclear would be a local, completely local life cycle that would not depend at all on Chinese supply chain. So that probably is the main reason why the government is switching. The Congress is now pushing on so hard on nuclear energy that before we were
So
mostly renewable.
yeah. So, Oscar, I'm jumping around in my questions here a little bit, but one of the driving forces here is the rise of AI, cloud computing, and cryptocurrency. These are sucking up unprecedented amounts of energy. And again, this is coming out of stories that you have posted on. So, I'm your number one fan in terms of nuclear power. I am following your stuff closely. And one of the things that has been interesting to read is the electricity consumption is projected to double by 2026, according to the U.S. Energy Information Administration, driving a 13 to 15% annual increase in power demand until 2030. So do you think that is, this need for energy is increasing? And I have more stats, again, coming from your stuff that I'll come back to. Do you think that's starting to drive this?
Yeah, well, that is why now the big companies, the Seven Magnificent, they are now turning to nuclear to see how to feed their data center. It's not only Microsoft that has been the biggest one, because they are just contracting all the energy of a nuclear plant for the next 20 years. So
yeah,
so it's a lot. It's a lot. They are paying about 16 billion for getting about 134 terawatt hours in the next 20 years. It's a lot. I mean, 134 terawatt hours is a lot. It's about twice the consumption of a country like Germany. So
well, let me break down some of the energy usages that go on in AI. A single chat GPT query uses roughly 2.9 watt hours of electricity, which is about 10 times more than the amount used for a Google search. But there are other AI tasks like image generation, right, which can use as much energy as charging a smartphone. Now, there is a caveat to this. As I was doing research online, at first I was shocked by the energy consumption. But as I read, people were saying, well, it still saves energy compared to having a person sit in front of a computer. So the advantage of nuclear basically is by putting the electricity near the data center. But overall, you may actually end up saving electricity, right?
yeah, well, not only it's a saving for a single search, because well, anyone that has used AI to search something knows that with a simple query, you most probably get the information you need. And if you use a Google search, probably you need to do several searches, and you don't get all the information you need, and it takes more time for you. The computer has to be turned on more time, and
Yeah.
that creates more. So it's true that AI is an improvement and it's more efficient, even though a single query gets a lot more, requires a lot more energy. But globally, it will drive more energy globally. And that's
Mm.
good. It's not bad, it's good. It's like, for instance, when we switch from coal to oil for transportation, yes, we had all those coal locomotives, all the trains were moved using coal. And now that we have better ways to move things, we have a lot more because it's a multiplier. And that is something that we will see from AI. AI is gonna multiply the productivity of the countries that embrace AI. It's like nuclear, for instance. I also share a few days ago, last week, that the International Monetary Fund calculated that nuclear energy, every dollar that a country invests in nuclear energy returns $4.19 in GPD, which is a multiplier. Obviously, the more you invest, the most you get, and the same is going to happen with AI. So
Yeah.
it requires energy, but it's going to be and it's more efficient, but that efficiency is going to drive more usage. So the global demand is going to grow, but the efficiency is going to grow a lot more. So in the end, it's a multiplier. It's a positive multiplier.
Oh, yeah. Well, and I took notes on that, actually. I took notes on that article. So the International Monetary Fund released a study indicating that nuclear power contributes 4.11 US dollars to the GDP for every dollar invested, right? Because we use energy to make money. We use energy to power our economy. Now, this is compared to only $1.19 for solar and wind. So it's like, 4 times as much, and only 65 cents for petroleum. Mm-hmm. So again, this is, I believe this is because energy costs are built into every step of the manufacturing and transportation logistics process in our economy, right? So, so every time someone has to touch something, they're using energy. We make these parts, we ship them around, we assemble them, we ship the final products. Energy is built into all of that. So nuclear helps us reduce the cost for everything, and it's multiplied.
Yes, exactly. Nuclear is very efficient. It's very dense. So due to be such a dense energy, you don't need much of it. You can actually a huge nuclear plant will requires about 1 truck of fuel every year. So it's almost nothing. It's nothing compared to the to the trains and trains and trains of coal that are required for a coal plant, or the huge amount of material that you need to build the same capacity using solar or wind. So that difference makes a lot of difference at the end in productivity, in economic numbers, so that's why nuclear is the best thing that we have so far, because it's the most dense, the densest energy that we have so far.
Well, and so coming back to AI and the tech industry, and again, let me apologize to yourself and to the audience because I'm jumping around on my questions, but so Microsoft this month secured a deal to reopen a reactor on 3 Mile Island. Amazon is working on putting a data center campus right next to the site of a Talon Energy nuclear power plant. Sam Altman, the CEO of OpenAI, is also heavily invested in nuclear energy. Mm-hmm. And Google CEO Sundar Pichai is considering using electricity from nuclear plants to power Google data centers. Yeah. So these are all recent stories. It's all big tech, and it's all in the headlines right now.
Yeah, and Oracle is planning the vision for the future data center will have 2 to 3 small modular reactors inside the data center. So they will be completely independent from the grid. And Microsoft is restarting a nuclear plant that was shut down 2 years ago, just because it wasn't 3 years ago, because it wasn't profitable back then. But now it is. And the same with Constellation, that is now restarting Palisades nuclear plant. And not only that, even Nextera Energy is considering restarting the Duane Arnold nuclear plant in Iowa. So we see it everywhere, that nuclear is now demanded, because the AI revolution is going to be duplicating their energy requirement every 2 years, and that's going to drive the global growth in energy. That, as you said, is McKinsey calculated that it was between 13 and 17% year over year. So it's a lot. It's the main driver, and the problem is that main driver requires reliable energy, and solar and wind, they are not reliable. So they are not in the equation. They are not on the table.
Yeah. Well, and going back to that, and again, I'm jumping around. I don't even have the question in front of me. But one of the things that you had written about was a study about the carcinogenic nature of different energy sources, which really surprised me. Solar and wind are actually far more carcinogenic than nuclear or even petroleum, which was, again, quite shocking.
Yes, it's shocking that the carcinogenic toxicity of wind, for instance, is about 11 CTU hours per terawatt hour, and about 8.4 for onshore. For solar PV, it's about 10 CTU hours per terawatt hour. For nuclear, it's about 0.5. So it's about 20 times less carcinogenic than solar and wind.
Yeah.
The question is, why? Well, it's clear. The nuclear plant and nuclear energy, the life cycle is very, very clean. It's not as dirty as the nuclear power, the nuclear weapons manufacturing, that is very, very dirty. It was and it is. And we have examples like Hanford and in UK, Sellafield. So those old nuclear weapon manufacturing facilities, they are very dirty. And people confuse one thing with the other. But nuclear energy, the life cycle is very, very clean. And all the waste, everything is contained. So there is no emission to the environment. So that waste is almost nothing. It's nothing. When you see it together, it fits into a football field. So the whole waste. So it's almost nothing. You can contain it easily. The radiation toxicity is reduced year over year naturally. You don't need to do anything, and in the end, it ends up not being toxic at all. That, for instance, all the chemicals, all the chemical toxicity of the life cycle in solar and wind, they last forever. So when you say, okay, it takes 1,000 years for the nuclear waste to become no waste. Yeah, but the waste from solar and wind takes forever. And it's a lot because you need like 2 times more material, 2 orders of magnitude more material than nuclear. So the waste is a lot more, and it lasts forever. And things like microplastic, carbon fiber, all those things that you can see that right now they are landfill, and they can degrade and go into the water table. That is something that we are not thinking about that at this time. We are just landfilling that, and that is really, really. I'm worried about that, because sooner or later we will have that in our food. Something that is never gonna happen with nuclear energy. So that's why the nuclear energy life cycle is 20 times cleaner than solar and wind, less carcinogenic. That is the only impact on health, and it's even more than coal, because coal has other impact on our health. Actually, it's even worse than solar and wind, but not on cancer. Is a problem with the breathing and all things in our lungs that it can develop. That is not cancer, but like asthma and other diseases, that is not cancer. Regarding cancer, solar and wind is more carcinogenic than coal. That is about 7.3 CTU hours per terawatt hour. So,
well, and taking into account that our energy needs are increasing, right? So if we stuck with coal and we tried to supplement with renewables, those risks and the drawbacks would be amplified because we have to continue increasing. And so one of the things that was really intriguing to me was a story you posted about the U.S. Department of Energy, quote unquote, aggressively pursuing the ambitious goal of tripling nuclear energy by 2050. And they apparently are actually looking at transitioning coal sites to nuclear reactors, as well as expanding some existing nuclear sites, right?
Yes. Well, the Department of Energy here in the U.S., it's really, really active. They are doing a lot of studies. So the utilities and companies, they don't need to do it because it's done. It's already done. The DOE has already identified all the coal sites that could be replaced with plug-in nuclear reactors. sharing the same buildings, the same power lines, the same. That power lines is a huge bottleneck in the development of the grids. You can save even the switch yards. I mean, most of the installations can be kept by replacing only the generation unit with a nuclear reactor. And yes, we can have almost 3 times the amount of gigawatts that we have at this time, just by doing that, by replacing coal with nuclear and expanding those nuclear sites that can be expanded. So all that work has been already done in the last couple of years by the DOE, and there is a huge push on that. And not only that, the Congress recently they changed, they released the Advance Act that was a bipartisan bill that is massively supported by the Congress, that changes completely the vision of the objective of the Nuclear Regulatory Commission, from a watchdog organization into an organization that is tasked to promote nuclear energy inside and outside our country. So that is a huge change. It's like night and day for the nuclear industry, because the regulator that before was just watchdog, just and putting red tapes on that. Now suddenly in the last 6 months, the NRC has done something that has never done, that is releasing the license to build not one but 2 advanced reactors. So that is something, one for Kairos and the other in Texas, in the Abilene University. So it's really a huge change, and it's visible. And the regulations has been eased for test reactors, for development reactors. So that's gonna they are doing everything that they can to make it easier, and they're not going to stop, obviously. So we are expecting more and more support, government support for that. We have the second line, that would be state governments, that, for instance, California is still banning nuclear energy. It's not banning coal or gas, but it's banning nuclear energy. That is a clean source. So it's kind of, and it's very difficult to understand. It's like the position in Germany. Germany and California, they share more or less the same vision. And they are sharing the same troubles that the companies are living because of that, because energy is very, very expensive, and energy is everywhere. So
well,
go on.
and again, I want to restate the energy consumption projections for AI, cloud computing, and cryptocurrency are projected to double by 2026, according to the U.S. Energy Information Administration, driving a 13 to 15% annual increase in power demand until 2030. So that is very substantial. And it makes sense that that is driving this renewed interest in nuclear. But people do have fears about this, right? We've had Fukushima, Chernobyl, and 3 Mile Island, and those have left an indelible mark in people's memories. Mm-hmm. So is there a way to guarantee that those don't happen again? Because, I mean, we heard guarantees before they happen, right?
There is no warranties. And if nuclear is going to expand, accidents will happen. That's for sure. We have to we cannot lie. It's going to happen. And it's going to be bad, but it's going to be worse than not going nuclear. That is the question. It's like aviation. Can we say that there won't be more aviation accidents? No, they're going to happen, even though flying is the safest transportation method. So in energy, nuclear is the same. Nuclear offers the safest energy, the lowest mortality per unit of energy generated. But that doesn't mean that nothing is going to happen. Of course it's going to happen. Regarding, for instance, the 3 main issues that we had in nuclear energy was 3 Mile Island, no one died. The maximum, the downwind dose was about a flight from New York to LA, nothing. We have Fukushima, no one died. The maximum downwind dose, if no one had been relocated, would have been like a CT scan. So all the measures that we see, all the people, all the images that we see is something that we are doing to clean something, but probably it's not required. It's something that we think about. Are we spending a lot of money for something that is not really necessary or that is not going to clean anything? And the only accident that had casualties was Chernobyl. Chernobyl, most people think that it's now a devastated land, but actually the people was relocated, except about 1,200 that decided not to relocate, to take the risk.
Okay.
Well, those 1,200 has more life expectancy than the average of those that were relocated. Yeah, and they're living off the land, having eating their crops, walking there, drinking the water, fishing in the ponds and rivers in the area. So they are living they're living off the land, and no one is dying. I mean, not more than people outside the area. To the point that now the population is more than 7,000 people living in the exclusion zone. So what has been the death toll? The death toll of Chernobyl is around 55, not more. And for cancer, only that happened after the accident is about 15, not more. And 4 of them was because a helicopter crash, not because of, I mean, it was the accident, it was caused by the accident, but not radiation or anything like that. So if we take into account the life saved by the Chernobyl plant, because it was nuclear instead of coal, Chernobyl actually has saved more lives than those that were taken. So even if a nuclear plant at the end of its life ends up like Chernobyl, it's even positive for the society as a whole.
Yeah, and so you're kind of going to the psychological aspects of this, right? In a way, this takes us there. I think one of the challenges that nuclear energy had was that it picked up a lot of the fear from the Cold War and nuclear weapons, right? Mm-hmm. And so hopefully now that we're some distance out from the Cold War, right, and we have a little bit more balanced view on energy sources, we can kind of separate those two a little bit more, right? People are terrified. I mean, they were terrified of nuclear war. I think that carried over to nuclear energy. But again, what you're saying is when you look at actual casualties from it, when you look at lives lost and environmental damage and pollution, nuclear is a lot better choice.
Yes. I mean, I think that the society in general, they have to do the same journey that the same journey that I did, because when I was in the 80s, I was a preteen. I remember going with my parents to anti-nuclear.
Okay, you protested.
Yeah. So, and I didn't know. They were telling that everything was bad and it was dangerous and blah. And so I agree with that. And I grew up thinking that nuclear was a really, really dangerous thing. And I until I was working in the nuclear energy industry, I didn't realize that, hey, it's not more dangerous than manufacturing chlorine or ammonia or any other toxic substance. And this is contained. If it's contained, it's fine, no problem. And even if there is radiation, we live in a radioactive environment. So we need to put things into context to when we need to check, hey, is this dangerous or not? So I did that journey from fearing that irrational fear that is called radiophobia, from suffering radiophobia and be against nuclear. Then my brain, my mind had to do an effort to move to, hey, no, this is safe. I understand that because I live that. I mean, I was afraid of nuclear energy, and even today, when I drive next to San Onofre, when I'm driving from San Diego to LA, that we pass by San Onofre, I feel inside that, hey, the inside there is a lot of radiation still and all that, and then my logic brain has to overcome that. Hey, yes, but it's contained, it's normal, everything is safe, and it's like flying. Obviously, flying is very dangerous because if something fail, you die.
Yeah.
You die. So it's the same. It's the same. It's something that is so dangerous, but the probability of having an issue is so low that the risk, which is severity times probability, is still very, very small. It's so small that it's several orders of magnitude below solar and wind. The dangers of the life cycle of solar and wind. So even you think that nuclear is expensive and it's dangerous, and it's not. It's
and there are also, I don't know what you would call it. It drives these related downstream effects, right? And so I was thinking of the pandemic. I saw a documentary movie about when the pandemic happened, the reduction in driving cleaned up the sky and people could see like the stars in Southern California for the first time. And, they talked about there was a region in India where they could see the mountains in the distance for the first time in over 50 years. And all of that is driven by petroleum, right? It's that petroleum smog and that junk that comes out of tailpipes. That goes down as we move to electric vehicles, and nuclear fits perfectly with electric vehicles, right? We don't need to power those with coal. We can swap that out. And so it doesn't eliminate issues with lithium mining. I realize there are still concerns there, but in terms of moving towards that clean society, it seems like this fits a lot better.
Yeah, well, the pandemic, showed us a lot of the effects of fossil fuels. Even the moon, the surface of the moon at night, and in the night, in the lunar night, throughout the lunar night, while the pandemic, the temperature was about 8 to 10 degrees lower because the radiation that it didn't receive from the Earth. So even the lunar surface was impacted by the pandemic.
So you're saying, so we're using enough fossil fuels right now. You're saying it's actually heating the surface of the moon.
Yeah, right now it's heating, and during the pandemic it was colder.
Yeah. So
yes,
that's time for change.
But regarding climate change, I'm pretty much agnostic because I don't see it clear. I see very reliable studies showing that the concentration of CO2 actually happens after the temperature, not before. So the causality, they are correlated, but probably we are confusing the causality. I'm not sure about that. But I believe that fossil fuels has to be phased out for two main reasons. One is pollution, because they are polluting. Even gas that fossil fuels advocates, they say that gas burns clean because it doesn't emit particulates, but it emits NO, nitrous oxides and sulfur, so other kind of pollution. Then we have the other factor, which is in case of a civilization critical event like an asteroid hit, a chain volcanic eruption, a nuclear war, a coronal mass ejection. There are many dangers that could be planetary catastrophes. So fossil fuels will be needed if we want to restart our civilization in a relatively short time frame. They're going to be needed. We will need easy to obtain, easy to use energy sources, because yes, fossil fuels are bad, but it's even worse not having any energy.
Well, and I don't anticipate fossil fuels going away. I mean, we use crude oil to manufacture far more, right? I mean, we make medicines, we make fertilizers, we make plastics out of it. So, the goal is not to get rid of it completely. It's just to try and get it out of, tailpipes, number one, right? And to use energy more efficiently. And again, coming back to our core theme today, AI and cryptocurrency and things like that, the energy consumption requirements, I think, are just going to push us beyond what we can do with these traditional sources.
Yes, and duplicating today's rate in 2 years. That is what this new expanding. Now they are in the exponential phase. So the initial expansion is going to be exponential. Yeah. That's why in 2026 is going to be twice the energy demand as we have today. So duplicating the energy demand in 2 years is a lot, and we're gonna see it, because globally, I mean, the data centers themselves, they are now they are requiring about the energy of Italy, more or less, more than the energy of Italy, between Italy and France, of energy only in data centers, which is a lot, and it's growing, and it's going to be duplicating in 2 years. So we're gonna, it's a lot more than what people believe, and that is gonna be, if we don't build a lot of reliable energy, well, the cost of energy is gonna be skyrocketing, or the cost of the internet services. I mean, everything. We will have a huge inflation problem, because energy is everywhere, everywhere. So absolutely. Yeah, we need to wake up early and quickly, and intermittent sources won't solve the issue. So we only have, if we want to go to reliable sources, we will have nuclear, geothermal, hydroelectric, and fossil fuels only. And we don't want fossil fuels because they are polluting. So if we take them out, we only have 3 options: hydroelectric, geothermal, and nuclear. So,
well, and we should come back to those in a future podcast. We should come back to I'm in Western Washington. A lot of our energy comes from hydro, right? And it is very inexpensive. It's plentiful. Geothermal is something I know that you have written about that as well. I would love to do a podcast on that in the future with you. But, in terms of nuclear, it seems like there's a lot of potential there. And another thing that I have seen over the last few years are a lot of reactor designs that are much safer, right? They're trying to ameliorate that fear. They're much safer. You've got these fail-safe designs, and you know about that, right? Where if an issue happens, it shuts down. So you in theory, you can't have a Fukushima, right?
Yeah, well, the advanced reactors, there are several technologies, but one of them is very very easy to understand. Current big reactors, they are pressurized. It's like a boiling reactor, that you have water in pressure, and everything is pressurized. The nuclear reactor is pressurized, but new technologies will allow us to not using water, but alternative fluids that allow them to work without pressure, at atmospheric pressure. So they cannot blow up, because there is no pressure. So they can blow out, and they can melt down, because the hotter that they get, the less energy they release. So they physically, it's impossible them to overheat. So those 2 measures makes the advanced reactors, some of them, a lot, not a lot more. It's almost accident free. I mean, you can have accident, but not different than whatever accident you can have in a chemical plant or something falling or, the typical industrial accident, not related to the specific technology, you know? So yes, it's but if you feel the fear that our generation, the baby boomers and Generation X, that we feel, that's not gonna go away if we tell. They have to see. So I encourage people to learn, to deep down, because anti-nuclear fears disappear for anyone to take care of investigate those concerns, because there is no concern. And I know what I'm talking about because I was on the other side, in the fear side. And I learned how to get rid of my fears by learning and by reading and by being there.
I would say that I am in very much the same boat. I think that there is this fear that's really in our cultural zeitgeist, and it's fading, but it has been there definitely since the Cold War and the threat of nuclear war. And, as you start to learn about nuclear energy, you realize, this is not the same thing. So,
yeah.
Well, Oscar, I want to close things down for today. Let me thank you so much for your time. Thank you for joining me. It has been truly wonderful having you back. I want to close by asking, what is coming up for you in the next few months? What's going on in Oscar's world?
Well, I would like to come back to the energy industry. I love this, but I'm in the aerospace industry.
Yeah, you are. Yeah.
And I love space. I love propulsion. I love physics, and I love energy. And I'm advocating for clean, reliable energies lately, because I believe that it's something that I have to do for my children and my future grandchildren, because it's something that if we don't do it, I think that they will have huge problems. And that's why I want to do this for them.
It is worth pointing out. Yeah, we are not paid spokespeople for the energy industry. This is not your industry or my industry, and so it is more of looking at what fits the best for future energy concerns.
Yeah.
So Oscar, thank you so much for your time, sir.
Thank you, Tim. It's always a pleasure talking with you.